Okay, today we're talking about scatter plots and lines of fit. So this was one of the sections in our chapter 4, but it wasn't on the test, so we're covering it now, and it will actually be what we're doing for the Mathletics test coming up. And if we haven't talked about the Mathletics test yet, basically what's happening is when you go to high school, a lot of the high schools have online homework, classwork, tests, quizzes, the whole 9 yards. You do it on something called WebEx, MathXL. There's another name for one of them. Anyways, it's products that come with your online textbook, and they have online tests and quizzes for you, so your teacher can assign it to you and sit back and watch you do work. And you usually do turn in your work still, or a lot of them require you to turn in like your scratch paper and stuff. But your answers are submitted online. Taking online tests is a skill. So we're going to start practicing now in 8th grade so that you are well prepared if that happens to you at high school. Okay, so that'll be our first Mathletics test, and we'll have several throughout this rest of the year. So scatter plots and lines of fit, let's get back to that. The first term we need to know is bivariate data. And bivariate data is data with two variables. So an X and a Y. We've been kind of doing lots of stuff with two variables recently. Our next term is scatter plots. You know, if we're going to talk about them, it'd be helpful to define them. Scatter plots show the relationships between a set of data with two variables, so that bivariate data, and we graph things with two variables as ordered pairs on a, what do we graph ordered pairs on? Good, a coordinate plane. Okay, so usually when we're talking scatter plots, we are only talking in the first quadrant of a coordinate plane. And there's a couple different things that can happen on these scatter plots. And in fact, I'll create 3 different scenarios. So let's say for the first scenario that we're going to measure, like our X value might be the hours you study, and the Y would be your score on the test. And this is a real thing. So maybe I only study like 30 minutes and I don't really know what I'm doing, so I get a score down here. And as I study, and these are all of you represented in the class, the more hours you study, the higher your grade is. Okay, so, and you'll see it kind of gets closer together because this is the ultimate achieving. If you study for, 3 hours for a test, you're gonna do better, hopefully. Granted, your studying is actually studying and not just playing on your phone. So when we're seeing this trend, if I could draw a line of fit through it, what kind of slope would this line of fit have? Good, hopefully it has positive slope. So this is called positive correlation. Okay. This next one, let's say our dots do something like that. What kind of correlation might that have? Good, negative correlation. And the last type happens like this. And obviously they might be a little bit more random than this, but this is as random as I'm getting. And you're looking for that line of fit, and you're going, holy cow, I don't even know. And that's because you're not seeing any correlation. In fact, you're looking at something that has no correlation. One thing does not have to do with the other. Okay? So something we just talked about when we were talking about correlation was a line of fit. And you saw me draw that line of fit through the positive correlation thing, and I could have easily drew one through the negative correlation. So a line of fit is defined as a trend line, or a line that models what's going on. Okay? So you'll notice when I say it's a trend line, that just means it's going to hit some of the points. It may not hit all of them. It's just giving you a basic idea of what's going on. Not all of those lines in the positive correlation, or not all of those dots in the positive correlation are on the line. And you will always have things that do not really fit to the line when we're talking about scatter plots. But the general idea is that the more you study, the higher your score is. It's increasing, it's positive. So I can draw that positive line of fit to get an idea of what's going on. Okay? So, with that, sometimes we will get data sets, and I don't always want to make you graph a data set because sometimes the numbers are really giant. But they'll always give us an x and a y. And let's say when x is 1, y is 151. When x is 2, y is 155. When x is 3, y is 255. When x is 4... Oh, I'm sorry, I'm messing up these numbers at the top. When x is 3, 1 is y55. When x is 5, it's 255. When x is 8, it's 230. When x is 12, it's 306. But it's also 300. And it's also 255. And it's 255 when x is 13. And when it's 15, it's 400. So you'll see there's a couple points where x is 12 and y is different things. So it's not a linear line. Like none of these points aren't going to connect magically unless you're doing like a dot to dot. But it's a trend. It's a scatter plot. If I plotted each one of these pieces of data, I would have a line of fit. Can anybody guess what kind of correlation these two sets have? Good, it's going to have positive correlation. Okay. And if I wanted to say, yes, it has positive correlation and I'm going to draw a line of fit, how would you find an equation for the line of fit? Well, first we have to ask, like, what form do we want to use? What form would you like to use, the easiest form to write a line in? Good, hopefully you said slope-intercept form, or that y equals mx plus b. Okay, so when we're looking at y equals mx plus b, one of the things we need to find, the first thing we need to find is m. Hopefully that's obvious at this point. So, and you know that m is y2 minus y1 over x2 minus x1. Okay? So it does not matter what 2 points you pick. I'm going to pick one from the beginning, so like this one, and one somewhere in the middle. Okay? That way I'm getting a fair assessment of what's going on. I'm not going to pick things that have the same x because obviously that will give me a denominator of 0. And that would be undefined. slope. And I don't want undefined slope because that doesn't tell me a lot about correlation. So I want things where I'm going to get that positive correlation out of it. So if I go ahead and plug in those numbers, I have 300 minus 151 over 12 minus 1, which would give me 149 over 11. That is not a really nice fraction, so I'm going to approximate it to a decimal. So that is approximately 13.5. Okay? So now I know that's my m. And I have y equals 13.5x plus b. And I'm going to take one of those points and plug it in, just like you normally do. And I'll take that first one because it's a little easier to work with an x that's 1. And I subtract that 13.5 to the other side. So I know that my b is equal to 137.5. And I'll take that and plug it in up here. So my equation for my line of fit would be y equals 13.5 x plus 137.5. Now, if I picked two different points from this, would I get the same line of fit? No. So go ahead and pick two different points than what I picked. You can do one of the same, but choose a different one and see if you get a completely different line of fit. They're all going to be real close together, and they're all going to be a positive slope because we're modeling something that has positive correlation. So go ahead and try that, and then we'll be done. Thanks for watching.